In this iMachining tutorial series, Video 1, we will create a milling cam part and iMachining operation. This video will cover saving and retrieving the example part file, adjusting default cam settings, and creating a new cam part definition. Finally, we will cover the basics of creating a new iMachining operation. We will create a new machine database, select a material database, select a simple closed pocket geometry, define a tool, select the levels, and simulate the toolpath. First, we'll need to open our example Inventor part. Please note that this part file does not come with the installation of InventorCAM. The example file will be included with this video tutorial. I placed this file in a training folder that I created on my C drive. I recommend you do the same. Now let's open up Inventor. In the Getting Started Operation ribbon, select Open. When the dialog opens, let's look in the C drive under Computer. Select the training folder from the list, and then choose the SC Aerospace Part 1 and open it. Before we begin, let's change the default CNC Controller. Go to the InventorCAM Operation ribbon, click on CAM Settings, go to Default CNC Controller in the list. Here, we can browse the database and select a Haas SSG milling post as our default CNC controller. Let's also disable the automatic cam part definition for both the stock and target. By default, these settings are enabled. Go to Automatic Cam Part Definition in the list, uncheck Definition of Stock and Definition of Target. Then, click OK to close the dialog. Now, this part is ready to go into InventorCAM for programming. We need to create a new cam part using the InventorCAM Operation ribbon. Click on the New icon and select Milling. Let's click OK to accept the file name and location for the InventorCAM part. Next, we will need to define the coordinate system, also known as the Part 0 for this job. Let's use the Select Face option to define the coordinate system. Then, we'll pick the back left corner as our origin, and then click Finish to accept. Now, we click OK to accept the default Z levels. Next, we will define the stock material for this job. We will define this stock by a 3D model since there is already a solid body created representing the stock material. Click on any portion of the stock body and then click Finish to accept the selection. Next, we'll need to define the target. Click Define 3D Model, right-click over the target geometry and select Other. In the drop-down, select any feature of the target and then click Finish to accept the selection. Now we can click Save and Exit to complete the cam part definition. To add a new iMachining operation, go to the InventorCAM Operation Manager on the left. Right-click Operations, select Add Operation, iMachining. Next, we will need to define the machine database. As you can see here, a Haas SS is included with the installation of InventorCAM for other walkthrough exercises. For this exercise, let's create a new machine database. Under the machine list, click the New icon. A dialog will prompt us to enter a name for the new machine database. Let's name it Haas SS New. Clicking Save verifies the database has been successfully created. There are 3 important values needed in the machine database. They are represented here by the yellow fields. We will need to enter the maximum RPM of the spindle, the maximum feed rate G1, and the maximum power of the spindle. Clicking Next will bring us to selecting a material database. These are provided. All we need to do is select the desired material. If there is no database matching the material we are cutting, selecting a similar material will be fine. Clicking Finish will bring up the iMachining Operation Manager. For this example, we will select a simple closed pocket. We will click Define and select one of the edges of a closed pocket. Clicking Auto Constant Z will close the geometry. Now, we can click Finish and bring back up the Operation Manager. Moving down the tree, next we need to create a new tool. Clicking Select will bring up the tool table. Click on the Add Milling Tool icon. This will be a flat end mill with a 1/2 inch or 12 millimeter diameter and 4 flutes. Clicking Select will close the tool table and bring back up the Operation Manager. Next on the tree are levels. Here, we'll need to pick the top of the stock as the upper level. Then, we'll also pick the pocket depth by right-clicking over the inside edge, as shown here. Now we click Save and Calculate. After the calculation, we can view the toolpath using the Simulation button on the bottom of the dialog. First, we can play the toolpath in HostCAD that shows the wireframe toolpath on the 3D model. Now, we can use Solid Verify to view the tool moving through the solid stock material. Finally, let's exit the simulation to bring back up the Operation Manager. And this concludes video 1 of the iMachining tutorial series, where we've created a milling cam part and iMachining operation. Thanks for watching. Please join us for video 2 of the series using the iMachining wizard.